Okay, so the first thing we talked about in the last module was really just, hi, what is cloud computing? How do people deploy against cloud? And then what does Amazon say are the 6 benefits against cloud, right? That's what we really talked about. And it was pretty straightforward. And honestly, most of those terms apply to any cloud provider, and the deployment models like the cloud versus on-premise versus hybrid, that applies to any deployment. I don't even know why they make the distinction, but we'll just roll with it. So we're going to talk, and there's a lot of stuff here. And literally, actually, I just taught this last night, which kind of cracks me up. Is that we're going to talk about virtual machines. That's really what this next module is about. And when I say that, you're probably going to be like, well, okay. Really what it is imagine taking your laptop or your desktop and digitizing the whole thing. Meaning we just converted it to live like in software on another computer. But then here's the catch. That operating system, let's say it's Windows, is actually out there running on somebody else's computer, and there's 1,000 of them. And they think they're running on real hardware, but they're not. They're running on fake hardware. And so you can kind of move them around because they think they're all on physical hardware. They think they're all on their same own laptops. And really what they're on is they're on fake laptops. And so you can just move them wherever you want to because they don't know that they're not sitting on physical hardware. They think they are. What this means also is that if you run 1,000 virtual machines and they all have Windows on them, you can actually log into them remotely, get the full visual GUI experience, and run software on them. Like you could run Office on all of them if you wanted to. So that's really what a virtual machine is. And they run on these massive like collections of servers. So like Amazon, I think at last estimate has like close to like 200,000 huge physical machines. And with those like 200,000 physical machines, they apparently run millions of virtual machines. Wow. And the reason for that is that the reason they can get away with that is that not everybody's using their laptop at the same time.
Yeah.
So, you know, in India, who's like, you know, what, 9.5 hours ahead, you know, they're doing stuff at 3 a.m. that we're definitely not doing, right? So the world over, Amazon's really figured this out where they've got all these servers hosting these operating systems. And sometimes they're sitting at 100%. And then the other like 5 operating systems are doing nothing because the owners are asleep. So that's kind of an oversimplification, but that's really how it works, right? If your website's based in the United States at 3 o'clock in the morning on a Saturday, nobody's probably doing anything with it unless you've got customers on the other side of the world, right? And so these businesses come and they buy these virtual machines, stand them up, but they don't really use them 100% all the time. It's very rare actually and just to say this, the industry average utilization for like an operating system that's been put out is 14%, which just so you know, is absolutely horrible. Can you imagine spending $10,000 on a laptop and you only used it 14% of the time?
I can't imagine.
I cannot.
I love that I get your answers. Because like, you know, like if you're a business and you buy a $10,000 laptop and you're only getting a 14% rate of return on the use of that laptop because you're only using it, what is that, 1/7 of the time? What did you buy it for? Right? So companies are always trying to maximize the use of their resources, but with Amazon, it works in their favor because they can now run these heterogeneous workloads on the same physical box. And on Sunday, someone's busy, and on Monday, someone else is busy. And so they never have to worry about crushing the actual physical hardware from a capacity standpoint because no one's active at the same time. So it's easy. So this is what the EC2 virtual machines are. The rest of these subjects, like where it says summarize elastic load balancing benefits, which is like the 5th or 6th one down, or describe differences between SNS and SQS. I'm just going to apologize to you right now, and it'll be the only time I apologize for at least this thing. I'll apologize for other things later. But you're about to enter an acronym buffet that you've probably never been in before. But knowing the acronyms makes you seem conversant in the technology, which actually you are. But like, just so you know, people are like, yeah, I was using SNS and we were running over a VPC and we changed our security groups and we did this. And it's like, it's a little bit of just a joke. It's like a little bit of like a tech nerd kind of like rite of passage that you can actually just speak in acronyms. And every company I've been at has them. So you're going to learn the acronyms because this is how people talk about the technology. It's weird.
I got my pad ready for all these acronyms.
Okay, good. Oh, and by the way, AWS has a glossary that has all the acronyms defined. Actually, let me grab that really quick because that will be useful to have, right? I was watching Tom Cruise break his ankle.
Oh my God, did he really? That's hilarious.
He did a stunt where he basically face planted against the side of a building, and he was supposed to do it, but none of his safety lines kicked in. And oddly enough, even though he landed face first, he broke his ankle.
Oh, that sucks.
He
Which
got
is-
lucky.
That's what they said, because if he had broken his jaw, that would have been a whole different experience. We probably know somebody who has experience with that. So,
They got mighty quiet on that one.
dude, she didn't say anything. She's probably on a call.
Y'all ain't right. I'm just saying.
That's nothing less true has ever been said. So, so just know that there is a glossary. So if you're looking for things like, hey, what's S3? Like you can find S3. It's a simple storage service. Like at one point, SNS is going to come up. So, oh God. Anyway, this is a glossary. So if you ever need to search for anything, you can actually grab that link, search in the guide. And to be frank, if you type in AWS glossary inside of Google, you're going to get to the glossary for AWS. So, so you can find anything you need to. Their documentation, I think I mentioned before, is actually pretty solid. Okay, so let's talk about virtual machines. Let's talk about some of the technologies they use to make virtual machines work better. And then we're going to talk about some weird messaging stuff, because honestly, there's just no other way to say it. You're like messaging stuff. Just bear with me. Okay, so we talked about the client server model before. You saw it, you understood it. Basically, we walk up, we ask for something, and then they give it to us, right? Those tend to be synchronous requests, which means we stand there, say, hey, can you give me the thing? And then they stay engaged with us until they give us the thing.
Mhm.
Sometimes our requests are asynchronous, which is really how it typically goes down in a coffee shop. We go and ask for something, we pay for it. That's a very synchronous act because they're expecting us to pay right then and there. And then we disengage and go stand off on the side. And then they like, hey, coffee for Michael. That's asynchronous. What they're doing is they're signaling you after you've broken away. They're saying, hey, by the way, I have the coffee that you've asked for. So just know that in these client server models, there's one where the response is expected right then and there. And there's others where the response is, I'll let you know when it's ready, right? And so they like trigger a response and say, hey, we're good. Come get your coffee, right? So just know that in the client server model, there's two types. There's synchronous and there's asynchronous. Asynchronous is the one you disconnect from, right? So virtual machines. So here's the weird thing. Like on your laptop, you've probably got at least one processor, which is a CPU that does all the processing and number crunching and everything else. You've probably got memory because why? Because that big brain that's doing all the number crunching needs somewhere fast to store data so it can actually pull it and crunch it and do all the stuff. Then you've got a hard drive, which is for long-term persistent data. So think of like memory as short-term, like memory, like for our brains, and think of like hard drives as like long-term memory. And so what happens is that when the number crunching happens and you're like working on a spreadsheet or a Word doc and you're like, hey, I want to save this in case I decide to turn myself off, you put it in long-term memory, so you stick it on the hard drive. That way, when the power goes off, the hard drive has persistent data on it, which then can be loaded back into memory, which then the CPU processor can do all the number crunching against. Now, in addition to having the basic subsystem of a processor, memory, and a hard drive, which is known as storage, typically, there's also network connectivity, which is of something that we've all got now because of the internet, right? So now not only is this system like in relationship to each other, but when it wants to talk to other computer systems, it runs across a network to talk to them. And that's really how like everything works now, is because we've got our phones and they're wired through cellular or wireless or whatever, and they're talking across the internet to connect to other services like Facebook or Snapchat or whatever we're using. So the reason that's significant is that these virtual machines have different characteristics around CPU, memory, networking, and hard drives. Those are the only four dimensions that really matter. Every once in a while, you'll see another dimension called video card, basically, also known as GPU, graphics processing unit. And the video cards are thrown in there because most people aren't aware now, but if you've been involved in any kind of like machine learning, artificial intelligence, or crypto, oddly enough, what we found out is that video cards, which had traditionally been what gamers use to make their gamers look pretty, their games look pretty, are also remarkably good at number crunching. So the traditional like CPU or processor is really good at most mathematical operations. But what we find is that GPUs, especially for certain types of math, are way faster than the complex CPUs we use for everything else. So CPU, memory, hard drive, networking, those are the 4 base components. Every once in a while, the video card, also known as the GPU, will show up as an option. So those 5 characteristics make up how a virtual machine is sized and the characteristics that it has. So Amazon, by the way, has a ridiculous number of types of virtual machines. So I'll talk about that. But there's general categories for the different types of virtual machines. But in terms of like the sheer catalog of the types of machines that you can get, there's probably like 500, which quite frankly is ridiculous. It's like walking in the cereal aisle and you got 500 different choices and you're like, I just wanted Cinnamon Life, or Fruity Pebbles. Although those are really sugary cereals. I'd probably die if I had those now. Anyway, moving on. So what happens is that when you go to, you say like, you're like, hey, I want a virtual machine. And by the way, you might say, well, what would I want a virtual machine for? Well, let's say you want to run a web server. That's a great reason to run a virtual machine. What you would do is you would actually launch the virtual machine with whatever characteristics you wanted. If you wanted Windows, if you wanted Linux, you could do that. You would launch it. It would boot up just like your laptop, just like your desktop. It boots up. So it goes from like a dead state basically to a live state. And then what happens is once it's up and running, because it's on Amazon's infrastructure, you have to connect to it. And there's several ways to do that. And, using various technologies, you can, tunnel into it. You can get a graphical interface if you want to into it. The bottom line is you have to log into it, maybe do some configuration, and then you're good to go. So if you want to run it, go ahead.
What does tunnel into it mean?
So for example, it might look something like this. So like this is what they call SSHing into a box. So this is non-graphical. Oops, I did not want to do that. This is non-graphical. So you can actually SSH into a remote box. Like let's say, this is probably not going to work, but because I just took that down. But what it would do is it would actually literally log me into a remote system, and then any command I ran on this little black screen right here would actually be reflected on the remote system, not the local system.
Gotcha. Okay.
So it's an SSH login. Sometimes they call it you can set up an SSH tunnel, but it's basically where I am SSHing, because that's the protocol, into a remote box, and then I'm acting like I'm typing commands like I'm on the box. This is non-graphical. There's another thing called remote desktop protocol that Windows has, and I'm pretty sure that's dead too. So I'll have to give you better examples next time. But when I click go, and if that system was up, it would literally take over my screen, and I would be on a remote Windows system. And then when I clicked my mouse and moved everything around, it would look like I'm on my local desktop, but I'm actually on a remote desktop.
Gotcha. Okay.
Yeah, and I'll show you some better examples later, so you can actually see that in action. But
I mean, I know this is a silly question, but like, what kind of security is on that? Like, in terms of, could I go into like, a computer cafe in China and log into that same desktop if I wanted to?
So it used to be that you could, because it was username and password based, right? So if you knew the username and you knew the password, you could log in. In the last 10 years, the industry has gotten away from using username and passwords for the most part to log into a system. What they do now is they give you this encrypted like data string. They give you basically a key that nobody else has. So like Dee would have her own key, you would have your own key, I would have my own key. And what would happen is you'd have to specify that key on the computer. You couldn't type it in. It has to be a file. So the file would have to be on the computer. And so when you went to log in, you'd have to submit that key. You would be the only person who would have it. And if you don't have that key, you can't get into the system.
So like if I had it on a USB, I could log in from China.
That's exactly right. You would have it on a USB drive. Or let's say it was on Google Drive and you could actually go and pull it down to the local system, then that would enable you to get access at that point.
We talking about that little key fob that changes like passwords every 1 minute that you had to carry with. Okay, I'm with you now.
So that's actually what's called multi-factor authentication. That's an enhancement to the key. So in that particular case, that little key fob works with the key to also add an additional layer of encryption where you basically have to enter in the little numbers that are displayed on the key. And if you get that wrong, it will let you in. So that's a two-factor authentication. So something you have and then something you know. In that case, something you have would be the actual key that we were just talking about. Something you know would be that little string that's on that little key fob that you'd have to type in.
I'm with you. Okay.
Yeah, and two-factor is pretty common for like Facebook and everybody else. They want you to not only know your password, which is something that you know, but they want to send a message to your phone because that's something you have. And so security is very focused on that two-factor where you know something and you have something that identifies you. Because then that way, if a hacker knows your password, but they try to get into your Facebook account, if they don't have your phone, then they can't get in. So that's very common. And enterprises who work with this kind of technology that we're talking about are much more stringent than we are individually. So like they are much tighter about this kind of stuff. So yeah. So this is the non-graphical way of hooking in, and that little remote desktop tool that I just showed you is a way of remote desktopping into a remote desktop. That kind of sounded redundant, but basically that's how you connect to the instance. Now, how you connect is very much dictated by the operating system. So if you're running Windows, you're going to log in with a remote desktop because that's graphically based. If you're running Linux, which is another type of operating system, then you're going to use SSH, which is that whole like black terminal screen that we just saw. I mean, in this particular case, I have a bunch of colors and stuff here, right? Because of like what I'm doing, but honestly, most people don't. It's literally just usually a really simple screen. So let me just switch to something else for a second. All right, that's a lot of stuff. Bear with me. Cool. All right. Sorry, I just needed to get something working. So you launch the instance after you've chosen all your characteristics. You connect to the instance and configure it if you want to. By the way, you can configure it at launch time. You don't have to configure it by logging into it. There's like ways to make it so that when it boots, it's configured and ready to go, which is kind of nice. Then you use it. So if you want to run a web server, it's a web server. If you need a database server, it's a database server. If you want to run some piece of code or an application, it's an application server. By the way, those are just arbitrary labels. You can use that operating system for whatever you want to, right? So it's not like it has to be a database server. It has to only be a web server. It's basically a server. You put whatever you want to run on there. And as long as you don't over capacitize it, you don't overuse it or oversaturate it, you can put everything you want on there. I've got buddies who are running servers out there and they probably have like 30 applications on there, but the box is strong enough to handle all 30 of those applications running at the same time. So not really an event. Now, I mentioned before that when you start a virtual machine, you have to make some decisions about the operating system, but you also have to t-shirt size it. Like what kind of virtual machine are you going to get? Like, do you want one that's built so it's got really strong processors? Do you want one that has a lot of memory? Do you want one that has a really fast network subsystem? Do you want one that has a lot of storage? Do you want one that has video cards on it? Remember, I said there were 5 different subsystems of a virtual machine: processor, memory, disk, networking, and then additionally GPU, right? Video cards. So Amazon has designed virtual machines for different purposes. So we'll talk about that. So in our coffee shop example, you can imagine that if all the employees are all doing everything, they don't really get good at anything, right? And so while I am a fan of generalism, right, we actually do become stronger if we actually specialize. So in this case, we've got someone who's really good at making coffee, and so they're really fast at it. We got someone who's really knows the front end cashier machine, so they're really good at it. And then we got somebody who maybe manages inventory and refreshes supplies, and they know where everything's at, and they're really good at it. Doesn't mean, by the way, you wouldn't necessarily cross-train them from a people perspective, but when designing machines, you don't use a hammer as a screwdriver. Now, as a man, I can tell you that I have dumbly, actually stupidly, tried to use a hammer as a screwdriver. And while you can make that work, it's kind of painful because, well, that's just what guys do. Now, if I try to use a screwdriver as a hammer, which I've also done, and that backfired on me as well, that's really not using the tool for what it's designed for. And so you just reap the consequences. Same thing with these virtual machines. They are designed for different purposes. So if one is designed to have a fast CPU, and you're like, man, I really wish this system had more memory. Well, unfortunately, unlike the screwdriver and the hammer example, you can't squeeze more memory out of a system that's optimized for CPUs, for processing. So you have to switch it, right? And Amazon makes it easy, by the way, for you to actually switch a virtual machine from one type to the next, and you don't lose any of your data, which is really cool because you can't do that in the real world, right? Only in the digital world. So with that being said, there are 5 general types of systems that Amazon has designed for our use. The first is called general purpose. Straightforward. What does it mean? It means it's a balanced system. It means it has a pretty consistent proportion of CPU, memory, disk, and networking. That's all that means. The second type of system is compute optimized. What does that mean? It means it has less memory and it's really heavy on the processor. The third type, well, it's memory optimized. You can probably figure this out. It has a lot of memory and moderate, average amounts of processor and everything else. Accelerated computing is the one that they named, and I literally am just like, why would you name it accelerated computing? No one knows what that means. Why isn't that intuitive? So let's just replace accelerated with GPU computing, which would have been a better name, honestly. So as you can imagine, having described the 5 subsystems, you now know that GPU computing means that these systems have video cards in them. By the way, most servers don't. So unlike our desktops and laptops, most servers don't actually have a strong video card in them. And the last type is storage optimized, which just like memory optimized, you can probably figure out what that means. It means it's got some strength to the disks subsystem. Now, the only one that we didn't list here out of the subsystems that we talked about that doesn't seem to have an optimization is networking. And the reason is that since this is actually on AWS's cloud, every one of these systems is already optimized for networking. So they don't have a network optimized instance because they're all optimized for networking. And just to be clear, our average internet connection ranks somewhere between like 20 to 100 megabits. That's the ranking typically. Some people are, if they're lucky, have a higher number on their network connection. These guys are 1,000 times that speed.
Yeah.
I know, it's weird. But these guys are connected to the internet at 1,000 times that speed. So like, for example, I'm on a 100 megabit connection, megabits. It's pretty good actually. And I never have any issue with streaming or whatnot. That storage optimized, one of these storage optimized systems is 25 gigabits, which a gigabit is 1,000 megabits. So it's 25,000 megabits. So I'm on 100. Those guys are running at 25,000 megabits. I'm pretty happy with 100. So I just want you to feel the scope of that because these systems from a network perspective are ridiculously fast. The slowest one, by the way, is 5,000 megabits, which, what is that, like 500 times my speed? So these systems don't have a network problem. So to go back, general purpose is balanced. Compute optimized has heavy on the processor. Memory optimized is heavy on memory. Accelerated computing is heavy on GPUs, and storage optimized is heavy on storage. So those are the 5 general classes. Now here's where we get in the weeds, and my own brain starts to burn down because even though I deal with this all the time, I'm like, Amazon, what are you doing? There's way too much detail here, but let's just go take a look at it. Please do not try and memorize this in any way, shape, or form. I just want you to see it. So if we go type in AWS instance types, what happens is that this actually takes us to Amazon's official documentation. And it says AWS EC2 instance types, which, these are basically the types of virtual machines. So they don't call them virtual machines, they call them instances. Why? I have no idea. I really don't. I think it's marketing speak. But see these little caveats on the left, these little categories: general purpose, compute optimized, memory optimized, the ones on the left-hand side.
Mhm.
These are exactly what we just looked at, right? The only thing that we didn't is, instance features is over here, and measuring instance performance, you can just leave that aside. But basically the 5 categories that we just looked at are listed right here. Now, underneath each of these 5 categories are specific flavors of virtual machine. But as you can see, I've actually clicked on general purpose. If I clicked on compute optimized, it changes the view. Now, here's the cool thing. You're gonna like this. All of the compute optimized instances, when we're actually like naming them, they start with C. That's actually pretty nice, right? So if someone says, hey, I'm running a C5 extra large, the minute you hear the word C, you're like, oh, it's a compute optimized instance. Now, whether it's a C5, a C6, or a C4, I don't care. Obviously, the higher the number, it's the latest generation. So if all of a sudden Amazon comes out with a C7, I'm like, oh, that's the latest generation of the C series, right? The thing that happens after it, and I'm going to pick on C4 here because it's a lot more simple. See how it says large, extra large, 2x large, 4x large, 8x large?
Mhm.
Amazon t-shirt sizes their particular virtual machines, which is awesome, because then it's really easy to figure out, because like an extra large is twice the size of a large. A 2x large is twice the size of an extra large. Like, then it's like, and you don't have to memorize the numbers. It's just nice to know that, like, oh, this is double the power. This is double the power. This is 4 times the power. This is 8 times the power. By the way, no one's memorizing these statistics. No one's going, Michael, I just looked and the C4 large is actually 2 processors and 3.7 gigahertz. Right? Nobody's doing that, just so we're clear. But you do need to know that this is how Amazon approaches sizing their virtual machines, and that every time you go up a size, you typically double. Now, let's look at the details. Before I do that, does anyone have any questions?
So I did. So I was actually trying to let me think of a business and figure out which one they would use as far as the compute. And for some reason, OnlyFans and Pornhub popped into my head because I'm so intrigued by that story recently. And I can't figure out if they would be using the graphics one for obvious reasons, or because of the amount of people. Because I think I read recently that they have the most traffic on the internet, literally in the world. So, or if they would just be using, I guess, not storage, but computation, I guess, for that much. I'm just trying to, my mind works weird. Which one would they be using based on?
Well, so they probably wouldn't be using the GPU ones, because the GPU ones are saved for either AI, crypto, or machine learning, like really hardcore number crunching.
Okay.
They're probably not using the GPU instances. For general web servers, which is, I'm assuming is what this on the front end, they're probably just using general purpose systems, right?
Really? Okay.
Well, because the web servers hit CPU, memory, and disk in networking pretty much equivalently.
Mhm.
They're hard on everything. So they would probably just have them stay in proportion to each other, and they would just get really large general purpose boxes. If for some reason their application was super memory intensive, then they probably use memory optimized, but they probably wouldn't. Those would be the only 2 options. They're probably not overpowering the processor. Most web servers overpower memory and networking, so it's probably general or memory.
Thank you. Just there you
Yeah.
go.
Yeah, no, it's good that you go through the exercise. Caroline, you were gonna say something?
Oh, no, that's what I guessed, actually. I was just guessing.
Yeah. You were guessing general purpose?
Yeah, I said general purpose or memory.
Yeah, good guess. And compute optimized tends to get used when they're doing a lot of generic number crunching, but they're not doing AI, crypto, or what they call machine learning. I'll explain what those are later, but when you hear the terms machine learning, artificial intelligence, or cryptocurrency of any type, those are pretty much going to be GPU focused activities. So, meaning they're going to try to use the GPUs for that.
Gotcha.
So the only thing that I can think of that would use compute would be, but I don't think they would use this, would be some kind of the stock market. Like what uses compute optimized?
Yeah, for example, number crunching, reporting, any kind of statistical analysis, geonomic number crunching, geospatial number crunching, geonomic being medical data, geospatial being any kind of like oil and gas kind of analysis, any atmospheric or environmental analysis where they're having to crunch a lot of like numbers, that would predominantly be on the compute optimized instances. The problem is that some of that data really benefits from machine learning perspectives being on GPUs. So you can really kind of straddle both worlds. I was actually just talking to an insurance company yesterday. I was teaching a class for them, and it was to a bunch of data scientists. So these are the machine learning guys, right? And the guy, the lead instructor, other than me, he works for them. They said, hey, just a reminder, you don't have to spend $1,000 a month on these like GPU boxes. You can actually just crunch it under a normal CPU. You should really save the GPU boxes for like deeper, more complex data sets. And so he was like, you could actually go both ways with this. There's benefits from using like a CPU processor to crunch data. There's benefits from using a GPU. In general, though, GPUs can only optimize certain data sets. A CPU can optimize all data sets. It just may not do certain ones as fast. So in general, there was this huge push for a while to use GPU systems. And now what we're finding is like, you know what? It may not be worth the extra cost. Let's just go ahead and stick with CPU-based systems, like our generic laptops and desktops. Why do we need to get specialized? So machine learning, artificial intelligence, and crypto all benefit from GPU options, but pretty much everything else works with CPUs.
Thank you.
Okay.
Yeah. So before I switch out on kind of like the family type, and like the C, by the way, defines the family type. So in this case, it's compute optimized. The number defines the generation. So the higher the number, the later the generation. General rule of thumb with AWS is that you want to use the latest generation possible because it's going to be cheaper and faster. And they keep doing that. Every time they release a new number, the price per CPU is lower and it's faster, which is just strange because you're like, wait, what? And it's like, oh, okay, so it's cheaper and faster. Let's just upgrade all our systems to this new type, right? And the t-shirt sizing hopefully makes sense. Now, if we're sticking just with the C4s, which by the way are pretty old at this point in time, but still very viable, notice that this is the CPU, this is the memory subsystem, this is the disk subsystem, also known as storage, and these are two network characteristics. The network performance is the one that probably is the most important. I would ignore this EBS thing for a second. I'll get to that. So what this means is that this has two processors and 3.75 gigabytes of RAM. This has 4 and 7.5, et cetera, et cetera. You can do the rest of that. Notice that they're not actually putting numbers on the network performance until you buy the largest machine possible, and they're basically telling you that it's 10,000 megabits. That's really fast. So, and this is an older system. But this is what we're talking about, is that there's 5 different flavors of just the C4 generation. If we switch over to the C5, look what just happened. Things got a little weird. We got bigger. There's more here, right? So excluding the metal, because we're not gonna deal with that. There's the large, X large, and notice it goes 2, 4, 9, 12, 18, and 24. Meaning that it's just multipliers of extra large at that point in time. So a 24 extra large is literally 24 times the size of an extra large. So see how this has 4 CPUs? If we multiply that times 24, we get 96. Because they t-shirt sized it. So it's not a 2XL, it's not a 3XL, it's a 24XL. Right? That's what they did. So that's what I mean by t-shirt sizing. Notice also that the memory was 8. If you multiply that times 24 and you pop up to this one, it should be 192 because 24 times 8 is 192. And by the way, I act like I'm just popping that off. It's only because I've said it a million times. I'm not doing like rapid math calculations all the time in my head. The other thing to note is, see how it says gigabits per second up here, and I keep talking about internet connectivity under network bandwidth? this is 25 gigabits for this 24 extra large, which is 25,000 megabits. So it's, you know, ludicrous speed, I think is what they said. And what was that movie?
Spaceballs.
Yeah. So just know it's ludicrous.
Ludicrous.
Okay. So the other thing that gets weird, though, just to say this, is that if this first letter is the family type and the second one's the generation, and this one's the t-shirt size, Amazon started hitting the hash pipe pretty hard in 2019, which more power to them. They needed it. And they decided to all of a sudden start adding letters after the number, which frankly made things weird. So if we look up here, by the way, see where it says C5A and C5N and C6GN and C6G? Those add different characteristics to the compute systems. Now, you don't have to know that. You just have to know that those letters mean that those systems are slightly different. They're special, not short bus special, but like different, right? So what this means is that, you know, for example, the C5A is actually using a special A and B processor. Do we care? No, we don't care. I don't know why Amazon did this, but regardless, just know that like they've added all these different flavors and whatever. The main thing you need to remember is that the first letter is the type and the number is the generation, and then you've got t-shirt sizes. Let's look at another one. So let's say we switch over to general purpose, and this is like is a minefield. So let's go to M5. All right, so you see this. M stands for medium, general purpose. 5 is the generation, and then notice the t-shirt sizes. Makes sense, right? Questions? Okay, so just know that the minute Amazon starts throwing letters after the number, you're gonna have to go read the documentation. You know why? Because we all do. Nobody has this memorized. I've been doing this for 10 years. They just started doing this in the last 2 years, and nobody has it memorized. So like, I don't even know what an M5ZN system is. Looks like it's using a special processor. Awesome. Most of the time, by the way, we don't care. We just want our software to run, and it's going to run. But the other thing to note is that while the compute optimized is clean, and so it's got nothing but C's in it, memory optimized is clean. It's got really pretty much nothing but R's in it. You can ignore the rest of these. Storage optimized has D's and I's. There's an H in here, but ignore that. Accelerated computing uses P's and G's as its main thing. The INFs and the Fs are like going away. So the point is that these letters, all these prefixes, all indicate the family type, and they all belong to certain families. And that's the main thing you need to be aware of. Do you need to memorize every single one? No. Remember that C stands for compute, M stands for median, R stands for memory or RAM, and D and I stand for data and IO, like input outputs. That's it. And remember that G stands for GPU. That's pretty much like the thing you want to focus on. Okay. Bottom line is that if you don't remember, you're going to go look at the documentation. No one's going to expect you to be able to rattle this off on the top of your head. It's not going to happen. Okay, so those are all the different flavors. Now, just to completely overwhelm you for just half a second, there's actually a list. That's not it. There's actually a list of all of the virtual machine sizes that you could get. And it's right here. So just try not to read this for a second. I'm just going to scroll down it. This is the entire list of possible virtual machines that you could get from AWS.
I just feel like that I could get a virtual machine of like a really high-end gaming computer and like game my little heart out for like, you know, $5 an hour that I wanted to play.
I don't know about $5 an hour, but you could actually, you could live your dream if you wanted to. So remember the M5s that we were talking about before? If I type in M5 up here, it will literally filter this entire list against just the M5s. So this is actually known as instances. Anyway, I'm just going to post the URL because someone just recently bought this and changed it. But this allows you to identify the kind of machine that you need. Let's say that you don't really care about the API name and someone came to UD and they were like, hey, I want a 2-processor system. So you put 2 here and you'd say, well, how much memory do you want? And they said 8 gigs. So this website is great for filtering out which types of machines would meet the 2 processor, 8 gig of RAM requirement. Notice it also threw 128s in there, but obviously the only thing we care about is the 8 gig systems, right?
Mhm.
So then you could look and say, well, the M5A or the M5DN or the T2 large, that meets the requirements. So maybe you just launch it and test it. What if they're like, well, hey, we want something that's a little more optimized for memory. So can we get something that has 16 gigs of RAM? And guess what? We're in the R series. See how it says R over here?
Yeah.
Because that would make sense, right? Because now we're emphasizing memory. Let's say we're like, you know what? Instead, I would like to emphasize more on the compute side of things, right? So we type in 4.0 and guess what shows up? A bunch of C's. And don't get me wrong, there's T's in here as well, but C's are the main system here. 2 CPUs, 4 gigs of RAM. So this website that I just posted a link for, this allows you to filter and search for the size of system that you need. Most of the time, whoever's asking you to do something in the cloud is going to provide you specifications. It's a little bit like going to a home and getting an architect to tell you exactly what you need to do this, that, and the other. There's going to be an architect who's going to basically say, I need a 4 processor, 16 gig system. You're going to go over here and you're going to type in 4 processors. You're going to type in 16 gigs of RAM, and these are going to be your options. Okay. And there's other subtleties here, but we're not going to cover those again until we actually get to the next phase. Okay. Questions about any of these types and what those little numbers mean?
I kind of noticed that all of them were Linux prices. When you pick a server, oftentimes it also includes Windows processing. Like, do you see how it says Linux on demand, Linux spot maximum? Okay, got it. I was just curious if there was an option for that.
So all of these virtual machines can run 3 operating systems, Windows and Linux, and a smaller subset can run Mac OS, which I got to tell you, I don't know why they did that. Nobody runs Mac OS in the enterprise.
I would assume just for game and app developers who are developing stuff on Mac.
Maybe, but usually they have their local laptop. So most Mac developers don't centralize off a central server. They just exchange. So I don't know. I mean, somebody has a valid use case because Amazon doesn't do anything unless the customer asks for it, but it must be really rare. So you can't actually get costs for Windows. Notice it says on demand, reserved, and blah, blah, blah. Those are just different types of licensing for the virtual machines. We're going to talk about those later. So notice, by the way, for example, that you can get a 2 CPU, 8 gig machine for 8 cents an hour.
Yeah, I think
Nice.
it's wonderful.
It's cheap. This is where Amazon really kills it, right? You can't buy a box like that for less than, what's the last time I saw it? $5,000, I think it was. To get an enterprise class machine, understand these are enterprise class machines. So like you can get a laptop with 2 processors and 8 gigs of RAM. That's not a problem. That'll cost you $1,000. But to get a server that like is resilient and able to withstand 100% processing use for years, you can't do that. You can't get that for less than $5,000. So the fact that they're charging 8 cents an hour, which what does that translate to? Like $2 a day. So that would be $60 a month on an average month for you to have an enterprise class system. And a 2x8 system could easily run a web server at scale. So,
And if you needed more, you could get more. If you need less, you could get less. You don't have to sell your old system or upgrade it or anything.
Exactly. So if you're like, hey, I bought 10 physical boxes and I need 5, you can't really give those back. Most of the time the manufacturer will take them. With AWS, they don't even care. You want 10 boxes, they'll give you 10. You want to give 9 of them back? They're like, great, we'll take them. They don't get they're all virtual, so it doesn't matter to them.
Hey Rishi, I just am enjoying this so much. I'm sorry that I have to leave, but
I know.
It's really, really fun.
Good. Well, and what I'll do is I'll pause the recording here, and then we'll pick the rest of it from there.
Thanks. I really appreciate it.
Oh, no
It's
problem.
fun being with you, Dee.
You too. I am.
Huh. I wonder why it says 1 hour and 53 minutes.
Maybe we should just, I think I might need to let this marinate in my mind for a minute, just full disclosure. Because